motion. Motion means I kept an object here. When I apply the force, this object moves and reaches up to here. If object or a particle changes its position, then we say that motion, the body is in motion. The object or particle must change its position. Then only we can say that it is in motion. Such motion is relative. Relative means here that particular quantity which has a particular quality, only when compared with another object, with another object or something else, particle. And motion of object totally depends on observer. Okay, for example, one passenger is sitting in the train and another passenger is on platform outside the train. If a passenger in a train throws an object, he thinks that he has thrown in a straight line. But the observer on platform observes that it is travelling in some parabolic path. The observation for him and both are correct only depending upon the place they are, the situations present there. The observer will observe that particular motion. Okay, how it is. Alright, now next we know about scalar quantity, right? Vector quantity. Now scalar quantity means that particular quantities which has only magnitude without direction. Examples are time, mass, etc. So magnitude means particular value. Vector quantity means that particular quantities which has magnitude as well as direction. Examples are velocity, acceleration, etc. Okay. Now let us define what is distance. So distance means, already now I said, no, if one body or object is here, if it moves from position A to position B, this length travelled, we call it as distance. So length or path travelled by an object from one point to other point, we call it as distance. And this distance has only magnitude. Now next, displacement. Now from the body A has to reach body B up to point B. Then that body, there are some possible ways. One is a person or a particle, directly they can travel from A to B, or in such a direction, or in such a way. Number of ways will be there for a person or a particle to travel from one point to other point. So if we compare these three ways, first and third way are a lengthy path travelled compared to the second path. So this second path is the shortest distance travelled by a person between A and B. So this shortest distance traveled, we call it as displacement, and this displacement has magnitude and direction. So distance means it has only magnitude, scalar quantity, and displacement is vector quantity which has the direction. So only I kept arrow here. That arrowhead indicates the direction of that particular object, in which direction it is traveling, right? Now next, if this distance changes with respect to the time, we call it as speed, and if this displacement changes with respect to the time, we call it as velocity. The units are meter per second. MKS system I am writing here, also meter per second itself only. Now next, the change in speed with respect to the time, or the rate of change of speed, we call it as average speed. Right? Now next, the speed, velocity, so the rate of change of velocity with respect to the time, we call it as acceleration. Okay. Now next, we can also write average speed. So I am discussing about these definitions. Average speed, what we can write? Average, we said no, means the total distance travelled in a particular time. Similarly, we can write average velocity. This is nothing but total displacement, the rate of change of total displacement. Here rate, in physics rate means what? Anything divided by time, we call it as rate. Means anything divided by time, we call it as rate. So rate of change of total displacement, average velocity. So velocity has or a specified direction, right? Because it is a vector quantity. Similarly, uniform motion. Uniform motion. So what is uniform motion? A body is said to be have uniform motion if it travels equal distances in equal intervals of time, or simply we can say that velocity is constant. Is constant, right? Similarly, we can also define uniform acceleration. Now what we can say? Okay, what we will say? If acceleration means if the change in velocity is the same, change in velocity is same, means velocity does not change. So in equal intervals of time we will find equal velocity. That we call it as uniform acceleration. Now next, rectilinear motion. Rectilinear means a straight line. Okay. So if the motion of the body is along a straight line, we call it as rectilinear motion. Next, deacceleration. Deacceleration means if velocity of object or a body decreases, we call it as deacceleration, right? And next we can also talk about the kinematic relations. So kinematic relation, it talks the relationship between final velocity, initial velocity, acceleration, time, displacement. So v equal to u plus at. V final velocity, u initial velocity, a acceleration, t time. Right? Now next, v square minus u square equal to 2as. S is the displacement. Okay? And next, s is equal to ut plus half at square with t as the time. So these are very useful for doing the problems. Okay? And this is independent of time, because time parameter is not involved, it is independent of time. So this we call it as kinematic relations, and this kinematic relations talks only about the motion of body without involvement of force. So these are some fundamental definitions which may be useful for you in the competitive exams. And these kinematic relations are useful for doing or deriving some problems also.